In this video, we are going to learn CQRS design pattern, which is the Command Query Responsibility Segregation pattern. CQRS is one of the important patterns when querying between microservices. We can use CQRS design pattern in order to avoid complex queries to get rid of the inefficient joins. CQRS stands for the Command and Query Responsibility Segregation pattern. Basically, this pattern separates read and write operation with separating databases. The main idea is that we can divide the application operation into two separate categories. The first one is commands. These commands are changing the state of data into application. And the second one is the queries. These queries are handling complex join operations, are returning a result and don't change the state of the data into the application. In large-scale microservice architectures, it needs to manage high-volume data requirements. For these kind of use cases, monolithic approaches like single database for services can cause bottlenecks. For complex and large-scale microservice architectures, we can use both CQRS and event sourcing patterns to improve application performance. CQRS offers to separate read and write data that provide to maximize query performance and scalability. Let's think about the monolithic applications. Most of the time we have one database, and this database should respond both query and update operations. That means a single database is both working for complex join operations and also perform CRUD operations. But if the application goes more complex, these query and CRUD operations will be also going to be unmanageable situation. In example of reading database, if your application required some query that needs to join more than 10 tables, this will lock the database due to latency of query computation. Also, if we give example of writing database, when performing the CRUD operations, we would need to make complex validations and process long business logics, so this will cause the lock database operations. So reading and writing database has different approaches that we can define different strategy to handle that operation. In order to that, CQRS offered to use separation of concerns principles and separate reading database and writing database with two databases. By this way, we can even use different database for reading and writing database types, like using NoSQL database for reading and using relational database for CRUD operations. Mostly, read database uses NoSQL databases with denormalized data, which generates from the write databases, and write database uses relational databases with fully normalized and supports strong data consistency. Another consideration is we should understand our application use case behaviors. If our application is mostly reading use cases and not writing so much, we can say that our application is read incentive application. So we should design our architecture as per our reading requirements with focusing on reading databases. So as a summary, read and write operation are asymmetrical and has very different performance and scale requirements. In order to improve query performance, the read operation perform queries from a highly denormalized materialized views of the data in order to avoid expensive repetitive table joins and table locks. At the same time, the write operation, which is the command operations, can perform commands into separate fully normalized relational databases, which is supporting the async transactions and strong data consistency. So we can say that CQRS separates read and write into different databases. Commands perform update data, query performs read data. Commands should be actions with task-based operations like add item into shopping cart or checkout order. So commands can be handled with message broker systems that provide to process commands in asynchronous way. And queries is never modify the database. Queries always return the JSON data with the DTO objects. By this way, we can isolate the commands and query operations. When we separate the read and write database for commands and queries, then we need to keep synchronous with the read and write databases. Basically, Whenever the write database is modified, it publishes an event that subscribes from the read database and updates the read database accordingly. This synchronization handles with the asynchronous communication using message brokers, and this creates eventual consistency principle that we will see in the upcoming videos. That means the read database eventually synchronized from the write database, but there may be some lag in the process due to asynchronous communication with message brokers that applies publish subscribe pattern. We will discuss eventual consistency in the next video.